Hello, everybody. Welcome to another episode of Millennium Live. Very happy to be coming to you in 2023 with a brand new episode. We have a healthcare discussion today, and it's going to be all about talking about AI and a company that gives providers, payers, and value-based care organizations the ability to make accurate, explainable, and actionable predictions of individual level health risks. Very excited to welcome Andrew I. He's the CEO and founder of ClosedLoop. Andrew, thanks for joining the Millennium Live Podcast.
Hey, Connor, thanks for having me. Excited to do it.
Great. So let's jump right into the questions and talk about AI a little bit, and just overall how the U.S. spends just an astronomical amount of money on healthcare, over $4 trillion spent in 2020 alone. I know that was a pandemic year, but let's talk AI and how AI can really transform healthcare and some of the benefits to doing so. And a second part of that question to start is really, why has healthcare in general been slow to adopt AI than other industries?
Yeah, so I think, folks who are listening to this podcast are already familiar with the problem in terms of kind of U.S. economy spending too much money to get worse outcomes than all other developed nations. When it comes to answering the question, how does artificial intelligence actually help, particularly in value-based care? I always try to make this simple and describe to folks, to succeed in value-based care, you got to be able to do two things fundamentally. You've got to be able to predict the future, and you've got to be able to change it. And by that, I mean, if you're operating in value-based care, ultimately, you've got to get really good at spotting adverse health events before they happen. That can be avoidable hospitalizations, readmissions, chronic disease onset and progression. You got to be able to spot those things before they happen. And then you've got to have intervention programs that actually work to prevent those adverse events from happening, right? You've got to actually be able to lower the cost of care. Where AI is really helpful, artificial intelligence, machine learning specifically, it's really good at using all of the data that a given organization has available to spot those adverse events before they happen, whether that's claims data, EMR data, labs data, social determinants of health, using all of that information to spot the bad event before it happens. That's AI's role. And so I think that's the first part of what you asked about, kind of, what is AI's role in driving down this total cost of care? So, the second part of the question, like, why hasn't AI been adopted more quickly? It's common in healthcare to just kind of complain about, like, oh my gosh, we're technology laggards and we're always behind. And, I don't find that to be true. I think in healthcare, if you look around, are we adopting AI slower than, let's say, marketing? Yeah, of course. The Facebooks of the world are building huge businesses using all the data they can to predict one question: what ad will you click on? Right. And that's how an entire generation has chosen to use artificial intelligence. It's just to target ads. We think there's a bigger opportunity. But I'll tell you, 5 years ago, if you asked me why isn't healthcare adopting AI faster, I would have been on the complaining bus. So I said, yeah, there's lots of problems with interoperability, and people are worried about messy data, and people are worried about whether or not AI is trying to steal their job as a physician. Those concerns have changed a lot in the last 2 years. And particularly, you asked about value-based care. In value-based care, we're seeing all of the winners in value-based care using machine learning and artificial intelligence to target their intervention programs. So, you can look around the industry and see folks are really adopting this technology widely now. So, I'm hearing more and more board level conversations where executives are saying, gosh, I'm worried that I'm behind because I'm seeing other folks who've already adopted this. It's not for the weird do my job for me use cases that people think. It's really about simple things like getting the right members enrolled in programs.
Is that a legitimate concern then that healthcare professionals have about, AI replacing their jobs or dictating what they do? How do you earn their trust?
Yeah, great question. So I think there were a couple things that happened, a few years ago that got everybody freaked out. Too many people saw too many sci-fi movies, right? And so people saw Ex Machina or iRobot or whatever, and they thought, like, AI equals a robot that walks around and does my job. That is not the application of artificial intelligence in healthcare. There are specific fields, like, I mean, if you look at radiology and the work that's being done in image analysis, yes, there is a labor savings to be had there, but that is not the majority of healthcare. The majority of healthcare is about diagnosis. It's about treatment. It's about spotting people that should be enrolled in a program. It's not about replacing the PCP. It's about spotting the patient who needs to see the PCP really bad, right? Getting the specialist involved when necessary, et cetera. So why do people kind of get freaked out about this? I think they got freaked out because they watched too many sci-fi movies, and the applications of artificial intelligence are way less sexy than people think. It's really about sorting spreadsheets. And by the way, we've already been sorting those spreadsheets, right? We have risk scores in healthcare that we use to identify people for programs. AI is just getting more accurate, more explainable risk scores to replace that old bad math, those bad, less accurate, less explainable predictions with more accurate, more explainable predictions. And so you asked, like, how do you do that? In artificial intelligence, particularly in healthcare, you got to show your work. So anytime you're surfacing a prediction, whether it's avoidable hospitalizations or, should we auto approve this prior authorization, or why do I think somebody doesn't have the proper coding, or why do I think somebody's likely to no show for an appointment? Whatever the use case, you better be ready to show your work and explain, not just at a population level, statistically, what did the model learn was important, but on an individual level. Why is Andrew on this list? Why is Andrew supposedly, at risk for developing heart disease, right? And you've got to be able to explain that in human readable terms. So more so than any other industry, certainly in fintech, if I get the stock prediction right, who cares how I got there, right?
Yeah.
But in healthcare, it's not enough to be accurate. You've got to be explainable at that individual patient level in terms a physician can understand, right?
Yeah, absolutely. And you mentioned this earlier already. So when organizations are considering new technology, they have to navigate the land of build versus buy in the decision-making process. So when it comes to this new technology, AI, ML, is one route more effective than the other?
So it's interesting, right? And I think this classification of like, hey, you get this build or buy decision, that is what the industry looked like 5 years ago. You had, and still to a large extent, you got a lot of people out there who they come to you with basically one of two value propositions if they're selling you something in artificial intelligence or machine learning. The first value proposition goes something like this. I've got the world's best algorithm. It's been trained on 500 billion people, more people than have ever lived on the planet, right? Like I've got all the data. I've got the world's best model because I trained it on the biggest population. And so fire your whole data science team. If you've hired anyone, you should fire them today and use my models, right? So that's kind of business model number one, which is the buy option, right? I've got the world's best algorithms, just use my algorithms. The second option is the build option. And so this starts with, well, all you need is a couple PhD students. Maybe, your cousin went to MIT, and so you should hire him because he's got a PhD in data science. And, they'll use some open source tools for a little while. And then, eventually we might need to buy some commercial tools for things like auto ML and ML ops and enterprise feature stores, whatever. But when you go down that path of tools for your data science team and hiring an army of data scientists, the problem is none of those tool vendors know squat about healthcare. And so you're explaining to them, what's an ICD-10 code? What are LOINC codes, right? And it's not just a problem of familiarity. It's a problem of like, they didn't build those technologies specifically for healthcare applications. So for the same reason, the horizontal vendors didn't win in the EMR space, right? We have specific products that were built specifically for healthcare. The same is true in artificial intelligence. Now, the first folks I was talking about who tell you to fire your data science team and use their models, the problem with that is healthcare is local. So the idea that I've got all the world's data, therefore I trained a model that's going to be perfect and accurate for you, it doesn't work in the real world because those models presuppose certain data inputs. They're expecting data coming into them that you may or may not have. They're also trained on patients that you don't see, meaning they've learned the patterns for a population that isn't applicable to you. So we've run this experiment tons of times. If I take an individual customer, train a model on just their population, and then I bring in external data, even from the same geography, for other patients that are like their patients but not their patients, the model accuracy goes down. He who has the most data doesn't win, right? The person, by adding data about patients that aren't mine, I learn patterns in patients I don't see. Now, there are exceptions to that rule, but the general theme is, because healthcare is local, right? We all know healthcare is local, the programs are local, the intervention ideas are different from geography to geography based on the realities on the ground. Models need to be local as well. So, build versus buy. Our approach, and it seems to be pretty unique in the industry, is build with, meaning Closed Loop provides tools to build bespoke predictive models for each individual customer, but we make that better, faster, cheaper. So we're bringing features and model templates to the table in addition to that end-to-end machine learning process. But at the end of the day, each customer's model is trained on their population using their data. So build or buy, our answer is build with Closed Loop, and then we'll hand you the keys. If you've got a data science team you want to build those models, we'll hand you the keys and show them how to do it better, faster, cheaper. If you don't have a data science team, we can bring data scientists to the fight as well, provide that turnkey solution. But at any point when you're ready to have your own data science team, we'll hand you the keys, let you handle the care and feeding.
I truly love that. Healthcare is local, and technology and data should be as well. I think that's great. How easy is it for your typical healthcare organization out there to incorporate these predictive models and these predictive analytics into their current infrastructure of what they have now? What are you seeing? Are certain organizations better prepared than others, and what do they need to know or have in order to go forward?
Yeah, again, as I was saying, it's interesting because 5 years ago, there's a lot of folks who weren't even looking at this yet, right? But now AI has become a board level conversation, right?
Has to.
CEOs, board executives, they see what's happening in their consumer lives. They see how powerful the technology is, so much so that you're like, is Alexa spying on me? Like, why are these ads so good? I swear they must be spying on me on my phone, right? So they see how powerful the technology is, and they want to know how to apply it in their own organizations. So where do they get started? How hard is it? Generally, I see folks on this kind of maturity curve. There's basically 3 big blocks. I haven't even started yet. I've got 0 to 2 data scientists. I've got no models in production. I'm thinking about open source tools and hiring a couple of PhD data scientists. So that's like just getting started, kind of a nascent stage. Then you've got folks who are like, well, no, we were there a year ago or 18 months ago. Now we've got a couple models in production, but oh geez, everything keeps breaking and the data feeds are fragile, and they're kind of at this early wins stage, where they got a couple of models in production. And then finally you end up with folks who have got like a team of 30 full-time data scientists. They've got dozens to hundreds of models in production, and now they're worried about maintenance and how do I keep these things up and running and what happens when the data feeds change and so forth. So along that spectrum, you've got people at all different parts of the journey, and they're encountering different problems depending on where they're getting started. So how do you get started? Well, if you're early, you're trying to figure out, what should I even be applying this technology to, right? So the problems are all about strategy, roadmap, getting to early wins so you can prove that AI can actually be a needle mover for your organization. And that can happen in like weeks to months, right? If you're doing this from scratch and you're trying to hire, if you think the solution is we're going to go hire a couple PhDs and give them a laptop, you're looking at 18 months. But if you're actually using kind of tools built specifically for healthcare, then we see folks, in as little as 90 days getting to those first proof of values and demonstration cases. For early wins folks, they've already got some of those under their belt. Now it's more about velocity and how do we kind of keep applying artificial intelligence across more use cases without scaling this huge maintenance cost. So those are some of the things that we're seeing just in terms of early adoption. And part of this is not only looking for when you're thinking about the first use cases, you don't want to think about only where's the biggest dollar impact and where is there enough predictive signal in my data. You also want to consider where do you have folks that are going to be your lighthouse wins within your organization. If you've got a VP of Population Health who says AI is never going to work, well, maybe that's not the best person to start with, right? But if you've got a VP of Pharmacy who's looking at, medication
Yeah.
adherence and they're really excited about it, well, I can tell you there are huge opportunities in both of those areas, but you want to be considering kind of where are your kind of business unit leaders really open to the idea of artificial intelligence, so you can go get those early wins and then fold out a larger strategy.
This is awesome, Andrew. It's great to listen to you here. Learning about all these AI solutions that can really develop timely predictive insights, which is awesome. I do want to get your perspective here, though. We're seeing a lot of big players come into the mix, like IBM and Amazon and Google and your other hyperscalers that are entering this healthcare market today. Something that also maybe we didn't see coming 5-7 years ago. What does this mean for the future of healthcare technology and perhaps small niche players like ClosedLoop?
Yeah, so it's interesting. In general, when you think about the major kind of cloud vendors, what they're interested in at the end of the day, their business model, and this is well established, but folks that are working in these kind of horizontal web scale kind of infrastructure sales, they are ultimately selling a utility, right? So just like you buy electricity, you buy internet, you buy gas, they are selling storage and compute. What they want is to collect all of the data from all the different verticals and have it all stored on their platform. I want you on Amazon and not on Google. I want you on Microsoft and not on Amazon, right? So they want to attract your storage and they want to attract your compute. Companies like ClosedLoop sit on top of those same platforms. And so the Amazons and Googles of the world are some of our strongest partners that introduce us to new customers, because ultimately what they're after is not because they're just nice guys, right? Their business model is dependent on attracting those that data and those compute cycles. And so our business models are super well aligned. And by the way, ClosedLoop makes it really easy to spin up a lot of compute cycles, right? Because we make it really easy to train new predictive models. So for them, what we see is they go as deep in any given vertical as they need to drive adoption within that vertical, right? They're looking for those proof points. And then they partner with folks like ClosedLoop. So again, the Amazons and Googles are very strong partners of ours. That's how we think about them.
Well, that's great, and I didn't really know that going into this. So, I want to switch gears just a little bit briefly, and perhaps could you talk a little bit about ClosedLoop and what challenges that you are seeing in the healthcare industry, that led someone like you to co-found this company and create these very unique solutions?
Yeah, so if folks start doing any LinkedIn stalking, they'll find pretty quickly that Andrew did not come from a 30-year healthcare background. I'm a technologist, started and sold a couple of tech companies in the information security space, the consumer mobile space. And so people always ask, like, well, hey, Andrew, what the heck are you doing in healthcare? And the short answer is my co-founder made me do it. Dave DiCaprio, our CTO and co-founder, Dave roped me into healthcare, really wanted to work with him after the last company. And, Dave had been working at MIT on the Human Genome Project at the Broad Institute, then worked in predictive analytics in the pharma market, then in the payer market. So he saw kind of this potential for the application of AI really at an individual patient level. So that's kind of where I got started. And then, like others, I got the bug, right? When we first kicked this off, I'd been a healthy guy my whole life, didn't really have any medical issues in our family. And then my youngest daughter got sick. And, I've talked a lot about this publicly, but, when you have that individual connection and you start to realize just how little our data is used, right? You go to the doctor, nobody says, well, hold on, let me run a model to see kind of, use all your historical health data or your family's historical health data to figure out what's the best course of action for you. That doesn't happen right now. And so seeing just my daughter's diagnostic odyssey and just how little our data was used is not that the clinicians aren't doing a fantastic job. We got wonderful care, but there's an opportunity to use that Facebook level intelligence that we see how powerful it is in our consumer lives to make better decisions in healthcare. So, it was when my own daughter got sick that I got the not just the what's the opportunity, piece, but the why am I doing this piece. And like others in healthcare, once you get that bug, then it's like, how could I ever go back to working on something that doesn't matter, right?
Yeah. Oh, that's a great story, and very impactful and meaningful as well. And just to back that up, so far Closed Loop has won some interesting awards and has been recognized recently. Class put up put out a healthcare artificial intelligence best in, and for this year, Closed Loop has won. And another interesting one, particularly that I noted, was in 2021, you won a contest that the Centers for Medicare and Medicaid held to develop AI solutions for healthcare. You guys won it. What was the challenge in regards to that? And what were some of the other players that participated, and why was it a significant win? Because I think it is.
Yeah, so those are two of the things that folks kind of tend to know us for. Class, obviously, number one analyst group in the healthcare IT industry specifically. And what I love about Class is based on direct customer feedback. So if you want to know what are folks saying about me, what are they saying about our competitors, you can read for yourself exactly what our customers and what other folks' customers are saying and what some of the challenges are. The CMS challenge win that you mentioned, yeah, that was kind of a $1.6 million X Prize, kind of like a DARPA Grand Challenge or an X Prize to build AI that physicians trust, right? So that contest, most machine learning contests become these like accuracy contests, right? Where if you can get 1/1000th of a point more accurate, then that's better. For the CMS challenge, there were three components. There was an accuracy component, but they also focused heavily on explainability. So specifically, building an interface that physicians could understand when you made a prediction. Why did you make that prediction? They were highlighting kind of the emphasis of trust, that at the end of the day, it doesn't matter how accurate our models are, because there's a decision maker between me and every potential insight that I might surface. And her name is doctor, right? And if I'm surfacing this insight, but the doctor doesn't buy it, then she's never going to act on it. And so CMS focused on explainability. And so they had a panel of physicians who reviewed the interfaces and said, yes, this would make sense to me, or no, it wouldn't. They had a series of questions that they asked. The third component that they had was around bias and fairness. And this is a huge topic. Senator Booker actually wrote to CMS and asked them to specifically address bias and fairness as a part of this challenge. CMS responded, CMMI, who's executing the contest. And so there was an entire section of the contest around bias and fairness and the specific issues that play out in healthcare. We've talked about this a ton. We've published our own statistics of a model that we came up for evaluating fairness we call group benefit equality, that we published on and kind of recommended. And so, those were the three core pillars. It was accuracy, explainability, and then bias and fairness. You asked kind of who participated. This was kind of the who's who of AI in healthcare. You had IBM, Accenture, Deloitte, Merck, Mayo Clinic, Geisinger, and yeah, that we always say, this little company in Austin nobody ever heard of won the whole darn thing. So it certainly put us on the map for a lot of folks who weren't aware of Closed Loop, and was a big jumping off point for some of the downstream success that we've had.
Well, that's awesome, and congratulations on that. And I can't wait to hear more about the future of Closed Loop. Solving the unsolvable problems, I guess, and bringing those new technologies into healthcare. It's awesome what you're doing. I just have a few more questions for you, and these are sort of nice, easy questions that our audience, I think, are now probably the most interested in. Could you perhaps provide a few examples of where you've seen AI and ML be particularly effective at predicting outcomes and ultimately preventing adverse health events?
Yeah, absolutely. So, one big category, particularly in value-based care, is kind of use cases around population health. So some of these are familiar to everybody because everybody's reinventing the same wheel. So lots of folks want to predict readmission risk, right? And why do they want to predict it? Well, they look at the people who are most likely to be readmitted, and they focus on appropriate transitions of care. So every time we talk about predicting something, my first question is always, what are you going to do different for the people at the top of the list, right? And so in the case of something like readmissions, we see huge improvements, a 75% improvement in accuracy in correctly predicting readmissions versus legacy risk scores like a Johns Hopkins ACG group or other rules-based systems. So we've got a number of cases where we're reducing readmissions or avoidable hospitalizations or avoidable ER. And those are pretty vanilla use cases. It's where most people start. But the things that get exciting are when you get past those first kind of things that need individual tailored risk scores based on a population, but are pretty familiar use cases. Some of my favorites are things like driving nephrology referrals based on risk of inpatient-initiated dialysis. So this is a little bit technical and in the weeds, but basically the gist is you want to spot people who are likely to progress from early stage chronic kidney disease to actually requiring dialysis, right? And so many dialysis starts happen in the hospital, and they cost about $50,000 more per patient if somebody starts dialysis in the emergency room rather than in an outpatient setting. So what do you do with that prediction? Well, you predict who's most likely to have an inpatient-initiated dialysis. You take the top of that list and you prioritize them for nephrology referrals. And the great thing about this use case is once I have outpatient-initiated dialysis, so if I get that nephrology referral, I show up and I actually do start dialysis in an outpatient setting, I, by definition, can never have inpatient-initiated dialysis, right? I've avoided that $50,000 in cost. So now, if you're trying to justify a $500,000 spend, you've only got to get it right 10 times in a year to get to break even. If you don't think you can spot that 10 times, then you shouldn't even be talking to anyone about artificial intelligence, right? But the dollar increments are so big, and that's just the financial side, like, let alone the infection rate and the adverse events that are associated. That's why the costs go up, right? So it's not just about the dollars and cents. It's about those patients who got the proper care before they got to this acute event that led to them being hospitalized, right? So those are the types of use cases that we love. And those are clear on the dollars and cents, but, you know, some of the most rewarding work we do is in, you know, Medicaid populations where you've got teen suicide risk, right? And we're able to identify those patients for whom you've got teens that need help with behavioral health referrals or social worker referrals, right? And those are the needles in the haystack that are not, again, it's not just about dollars and cents. It's about actually being able to save lives, right? And improve health using the same technology that we already know works in our consumer lives.
Of course. And why not? And, you know, a question that I had and that I was curious about, you know, in today's world, we wear a lot of wearable tech, and even on our phones, we have, and through health apps, you know, it's generating a huge amount of data about us, you know, counting our steps, our heart rate, and things like that. But that's rarely captured when in the chart, when you go and have your annual physical, you know, as interoperability improves, I'm sure the patient's experience will change. What does that look like in the future?
Yeah, I love it, Connor. You're a futurist. You're a believer. So you're already like 3 years down the path, right? 5 years down the path. I love these kinds of questions, but, you know, so where do I think this goes? Let me answer your question first, and then I'll give you a more practical answer. So where do I think this goes? Where I think this goes is right now, your doctor doesn't want to see your stupid Apple Watch data, right? And why not? Because they got 1,000 other things to look at, and it's not actionable. And like, the point is information overload. So,
Right.
but this is exactly where artificial intelligence can help. Your doctor doesn't need to know your Apple Watch ratings unless something bad and anomalous that is likely to lead to an adverse event happens. So I see a future in which we're powering these same questions, right? Who's most likely to have an avoidable hospitalization? Who's most likely to end up in the emergency room? Who's most likely to progress in a chronic disease? We're going to power those same questions, not just with EMR data and claims data. We're going to power those same questions more accurately and in a more timely fashion and in an explainable fashion with that Apple Watch data. But that's in the future. That's for the believers. You don't need that data. How about if we just look at your lab values? This data is available now. How about if we just look at all your prior diagnoses? I don't need your Apple Watch to get to 95% confidence on who's going to have an avoidable hospitalization. We can do that with the data you already have. And so, love the vision, love the future. I want my Apple Watch data going to my doctor too. But the here and now is just use claims data, EMR data, labs data, ADT data, social determinants of health data. Use the data we've already got to do a better job with the problems we already have.
Yeah, I totally agree with that. I could probably continue this conversation for much longer, but I can't let you go without asking you one final question. You guys are on a mission to improve health and transform care with your predictive analytics and your AI and data science. I can't wait to see where it's going, and I'm sure there's listeners in our audience that want to know more and are interested in incorporating this. So, what's the easiest point of entry for an organization that wants to get started in incorporating data science into their care decisions?
As I mentioned earlier, there's so many use cases in healthcare where you're already using a predictive algorithm and you don't even realize it, right? Anytime you see a risk score, readmission risk, avoidable hospitalizations risk, just generic risk, anytime you see that, that is bad math. It's old legacy predictive models that are based on a very small set of rules. Those legacy risk scores are one of the easiest ways to get started because the change management's really simple. You're sorting the list today based on a risk score, sort it with a better risk score based on machine learning and artificial intelligence. That's a really easy integration point. Lots of those in pop health, but you see this with rules-based things all the time. Somebody will have built out a rules-based thing that says what's the risk of no show for an appointment, and they will have done that with like 3 prior rules, right? So for each of those use cases, anytime you see a risk of, those are really easy integration points with very low change management barriers. In terms of like, how do you get in touch with us or how do you look at this? I always point people to KLAS. So the KLAS Healthcare AI report talks about a lot of the challenges and issues that people are facing. Yes, we are #1 in that report. So we hope you're going to call us after you read it. And you can reach us very simply at ClosedLoop.ai, www.closedloop.ai. I think that's where I would point folks to get started.
Well, this has been a great conversation. Thank you, Andrew, for just the insights and the knowledge. It's looking like an exciting year ahead at Closed Loop.
Thanks so much, Connor. Great talking to you.